everyone. Thank you for being here. My name is Tatiana McGee, and I'm currently a student at Appalachian State University. I transferred there in 2016. I'm currently a senior who's double majoring in geography and community and regional planning with a GIS certificate. I'm also working towards a Master's of Arts in general geography. My motivation for this project came from studying abroad last summer in Peru with Dr. Baker Perry. That was the first time I was really able to see geographic research being done and seeing its impact at a small and large scale. This kind of motivated me to start investing more time and thinking critically whenever given creative freedom in a project instead of just going for the easy route and doing projects and working with data that I'm familiar with or have a background in. My motivation for this project was to manipulate, visualize, and analyze environmental data that has a human component, whether that be anthropogenic influences with the problem or effects that it can have on humans as well. I also wanted to choose a topic that I wasn't really familiar with to not only learn more about the GIS tools and the layout of ArcMap, but also wanted to learn more about the topic itself. So I really wanted to avoid census data. Dr. Derek Martin was my professor for quantitative methods my first semester at App. He has done geomorphology in Missouri. He went to the University of Missouri and talked a lot about his research out there with karst topography, sinkholes, disappearing streams, and that topic has always really interested me. I haven't been able to take a class on it or really focus on it, so whenever I was given the creative freedom for my advanced GIS project, I decided to delve in a little bit deeper and become more familiar with the topic and see how it relates to humans in the area. Dr. Jeff Colby was my professor and is still my professor for geocomputation, but he was my professor for advanced GIS, which this project was made for. He helped me a lot in introducing me to new methods and tools in ArcMap that I was not introduced to or worked with before in previous labs. He was also always there to help reassure me whenever things did not go as planned, which happened a lot. My objective for this project was to visualize areas susceptible to sinkholes in Missouri. I took static water level, infrastructure density, and sinkhole density into account. The first step in visualizing at-risk areas and their susceptibility for sinkholes was to narrow in on what I wanted that area to be. I knew I wanted the state of Missouri, not only because of Derek Martin's background in it and his ability to mentor me throughout this project, but because of the presence of karst topography. I didn't want to choose an area simply because karst topography was present, because in the state of Missouri, it's found throughout the Ozark region. But I wanted to choose an area that was susceptible to erosive formations because of the karst topography. After doing a little bit of research, I quickly found out that Perry County right there is a hotspot for that sort of activity. It has the most caves out of any county in Missouri with 667 caves. It's also home to the longest cave, Crevice Cave, at a total of 31.2 miles. So that allowed me to narrow in on that for my study area. Data-wise, since I did want to avoid using census data, I ran into some problems in finding data. It was a lot harder than I thought it was going to be. So I eventually had to email the University of Missouri and see if they had any databases that they could grant me access to or any links of other federal and or state government databases. They introduced me to MSDIS and GeoStrat, where I was able to find the building footprints, well data, sinkhole data, the Perry County outline, as well as the state of Missouri karst layer as well from USGS. Temporally, my data varies. The only two layers that are from the same year are the sinkhole points and the karst map, but I still believe that temporally that the scale was appropriate enough for my study. For my project, I used the Universal Transverse Mercator for Zone 15 North, because that is where the state of Missouri is located in, as well as Perry County. Perry County also does not have an intersect. It's all located within that one area. I also use NAD 83 for the data. Some information as to why karst topography is such an influential factor in my project is because of the creation of hollow subterranean environments. Karst is very erosive when introduced to water. Therefore, whenever there is water present, it can form caves, but not just large caves like crevice caves, but also under infrastructure. A lot of times people don't know what the subterranean environment looks like. And in these areas, the water level plays a very big role in sustaining and giving integrity to the surface above it. And that's where the static water level comes into play. The static water level is measured by the distance between the ground surface and the water present within a well. Therefore, the greater the distance, the lower the static water level. Karst topography is known to create erosive formations such as sinkholes, but researchers, as well as Derek Martin, introduced me to the influence that humans and human activity can play into it as well. As population increases, so does the development in order to provide housing and support the public health, safety, and welfare. And as development increases, so does the weight on the land surface and the weight that the land surface has to support. In these hollow subterranean environments, if the water level is low, I hypothesize that it would be less, the ground would have less integrity. Therefore, whenever I was doing my analysis, I was looking for areas with low static water level because I suppose that higher sinkhole formations would be occurring there. And that is where my infrastructure data layer came from. As well as causing increased development, increased population causes an increase in water demand. As water demand increases, more water is needing to be pumped from the ground, which would result in lower static water levels. And that is where that layer came from. By combining sinkhole density, infrastructure, and low static water level, all with equal weights, I was able to create a map that visualized areas that were susceptible to sinkhole formation. Again, all these are added equally. There were no weightings given to any layer. But I wanted to go a step further with my analysis and add weights in order to see how the influencing factors of sinkhole formation, from adding weights to them, how would the spatial extent of susceptibility change, and see which layers would correlate more, if any layers would correlate at all. I hypothesized that sinkhole density, infrastructure, and static water level, all three of those layers and maps, would correlate evenly. I prioritized the layer using 0.75 because it not only created that layer as a priority over the others, but I believe that 0.75 was conceptually easier to understand than another decimal point. And these weightings created 3 separate layers, and each layer, only one data layer is prioritized at a time. I asked 3 research questions before creating my project. I wanted to know what areas were susceptible to sinkhole formation in Perry, Missouri, located right over here. I wanted to ask what outside factors could also influence susceptibility of areas, because I knew that infrastructure and static water level would and could not only be the only influencing factors of sinkhole formation. And I wanted to see how prioritizing the influencing factors of low static water level, building density, and sinkhole density would change the spatial extent of susceptible areas. Or in other words, how would the map of each prioritization change, and the relationship with each other. My methodology, these were all my beginning layers. In order to create a continuous raster surface, I needed to convert my well data, my structure data, and my sinkhole point vector data into raster. I used a inverse distance weighted, or IDW, for the wells, where static water level was an attribute column. So I just used that attribute column, did the IDW just on that. I did a simple point density conversion for the structure and sinkhole data right over here. After doing that, I reclassified them into 10 groups. When reclassifying them, the largest number for each data set was given the highest importance, because the more structure density there is, I hypothesize the more susceptibility to sinkhole formation. Same with sinkhole density. For static water level, the data was given as the distance between the ground surface and the water level. Therefore, the greater the number, the greater the distance, and the lower the static water level. Methodology continued. After reclassifying them, I went into map algebra, and for one, I combined them without any prioritization, all equal weightings. And then for the other three, this is whenever I did the 0.75 prioritization in order to create three distinct maps. I then clipped them to the Perry, Missouri County outline and had my final four products. One where the layers are equally weighted, and then these three in which one is prioritized. They're sinkholes, static water level, and then the sinkholes, static water level, and structure. Right over there. Methodology continued. For my cell size, I chose 10 meters because I believe that it would allow for accurate spatial analysis while not creating too fine or too coarse of a resolution. I used Jenks natural breaks for my classification system because I believed it took the natural breaks in the environmental data of sinkholes and static water level into account. And I just used 10 classes because it was pretty easy for me and other individuals to understand. This was my first map where all three layers are combined evenly. I hypothesized that this area would have a high correlation because that's where Perryville, the largest city in Perry County, is. Therefore, I believe that there would be a lower static water level, higher building density, and I assume there would be a higher sinkhole formation. What I found interesting was that there was this area that kind of just branched out of Perryville, where there was also a really high correlation, which I was not expecting to find at all because that is outside city limits. So I was kind of curious as to, was it infrastructure that was creating that, or was it the low static water level, or maybe an outside factor that I hadn't really considered? Also, my highs and lows are 23 and 3 and not 30 and 0 because there was no area that was present that had like a high maximum prioritization of all three factors. You can see the Mississippi floodplain on the eastern portion of the county, and then the introduction of the Ozark Plateau right over here, which is where the karst topography is beginning to be found, where you can see that's where high correlation starts to take place in the county. This is the same map, but I overlaid sinkhole and well point data. This was very interesting to see because the density of wells didn't necessarily correlate with the density of sinkholes like I hypothesized. I immediately met with Dr. Martin because I thought all my research was wrong because I totally expected that to happen. But since he did study in the University of Missouri and has done research in the area, he introduced me to various outside factors that could have resulted in lower static water levels. He suggested that the wells that are present are just pumping exponentially more water than the other wells because of beef cattle farming, which was something I did not consider at all, and also just outsourcing water for the city of Perryville. These are cows, and then this is Saline Creek, which is where Perryville is getting 70% of their water from. Perry County had a population of 19,225 people, but had a population of 47,000 cows, which 15,900 of them were beef cattle. This is important because beef cattle require a lot more water than normal cows because you have to support the cow, irrigation, meat processing, which I was not expecting to put this in my research, but that is definitely an influencing factor in the water demand in that little area that branches off out of Perryville. Perryville had used approximately 415 million gallons of water, and about 290 million of those were outsourced from Saline Creek. I wasn't able to find any data on Saline Creek or where it runs or how much water it produces, but this results in 70% of the water being found outside of Perryville, which I believe could also influence the static water levels and sinkhole formation outside of where I believed it was going to be. This next map shows a prioritization on high sinkhole density. Again, I expected this because this is where Perryville is found, but I was not expecting this cluster towards the northeast. In this map, the infrastructure density is highlighted, which you can almost see the city limits within Perryville. This map shows that right here definitely does not have as much density, so it would either have to be a low static water level that was influencing the sinkhole formation, or a whole nother data layer that I was not considering. When I take the low static water levels into account, I'm able to see that this cluster is present as seen in the initial combination. That led me to believe that there was a higher correlation between low static water levels and sinkhole formation rather than high infrastructure density and sinkhole formation. In conclusion, low static water level appears to correlate more with sinkhole susceptibility than infrastructure density. Also, well depths and extraction rates are more influential than well density. As you can see, these both have the same little cluster area, while Perryville is concentrated right over there. Who does this help? This can help civil engineers, local government officials, developers, planners, insurance agencies, and prospective home buyers. Also, it can help the city of Perryville itself. If it is to grow and produce sprawl, it probably does not want to go northeast if there's going to be a lot of sinkholes. Continued analysis, I would like to add a beef cattle farming data in shapefile to it to see its correlation to the static water level. Perryville water sourcing data, figuring out where Perryville is getting its water, where Saline Creek is located, a Saline Creek shapefile, well depth and extraction data, as well as land use and high sinkhole density data, because I was introduced to beef cattle as an influence in low static water levels, and I'm sure there are other influencing factors as well. Also, I learned recently that MSDIS and GeoStrat just updated their databases and have new 2018 data, which would be very helpful than 2012 and 2014. Thank you for your time. Does anyone have any questions?
What did you consider the minimum size, maximum size of a sinkhole by definition? What was the average size?
Ooh, the average. I just downloaded one entire layer of all the sinkhole that the Missouri state government created. Just one layer with all the points. They didn't really have a definition or a criteria as to what a sinkhole was, just whenever it was reported. I'm sure they range from extensive, large ones that could swallow like the homes, but also just small ones in your front yard. But there wasn't really a criteria that I was aware of that it had to meet. Any other questions? Thank you.